Thank you all very much for coming to class. I hope you're having a good Thursday. Today is intended to be the last day that we cover new content. Um, on Tuesday, my intention is to only have kind of a review. Um, but if there's anything that we don't wrap up today, I'll capture it on Tuesday. And I'll definitely let you know, like, hey, this is where the content for this first exam stops. Now, with that in mind, today we're going over quite a bit of stuff. We're going to focus on bonding. We're going to focus in on, well, when you have a compound, well, how's it made basically? Um, you've got some practice exam questions up, I believe. Um, I am in the process of writing your actual exam. So as soon as I have your actual exam written completely, I'll give you guys like, hey, though we covered all of this stuff, here are some primary, learning objectives to go after. But again, okay, I'm not muted. Again, on Tuesday, we're going to be doing a more comprehensive review over what is going to be on the test. So I'll go ahead and get started. And I've got office hours today at 11. If you want to hang around after class, ask some questions, I'm more than happy to do that. But if you want to come to office hours, follow the office hours link. Okay, so bonding is what we were talking about today. Now, our learning objectives for today's content are, well, what are the common ions that are specified in this slide deck? What are the names of common ions? Convert from formula to name, convert from name to formula. What is the significance of Roman numerals in ionic compounds? What is the octet rule and how is it applied? What's the difference between a polar and nonpolar bond? What's electronegativity? How many bonds will an atom make? Naming covalent compounds. What are the polyatomic ions and how do you name a compound with them? Now, all of this kind of collectively leads to, well, how molecules are formed. And what this relates ultimately to is, get my pen, electrons. Are they, and I will go ahead and add this, um, are they shared or are they donated? And when I said donated, I mean gained, lost, gained or lost. Um, so last time we talked about NaCl, the formation of NaCl. And if you think about the Lewis structure for sodium, well, you're going to show that Lewis structure by drawing the symbol and then putting a single dot. And if you remember the sequence of our Lewis dot structures, we did an X and then our first electron, second, third, fourth, then fifth, sixth, seventh, and eighth. Um, were there more electrons than eight that we put around a Lewis structure? Add to the chat Y or N. Add Y if we do add more than eight electrons, or an N if no, we don't. Excellent. You're absolutely right. We don't add more than that. Okay. Now back to this point of electrons, and well, we have Cl one, two, three, four, five, six, seven. Okay, so chlorine has seven electrons around it. Sodium donates a single electron. So sodium loses an electron and chlorine accepts it so that chlorine can get to a Lewis dot symbol that looks like this. Now, whenever I draw this Lewis dot symbol like this, and what am I missing from this? What am I missing from this depiction right here? I've got my eight electrons around it, which is correct because chlorine has accepted that eighth electron. But there's one thing that I'm missing. A charge. You're absolutely right. Chlorine. Now, with that being established, and I completely agree with you, is this going to be a positive or a negative? What should my charge be? Negative is correct because what did I gain? Yeah, I know that it's tempting to say, oh, it's positive because you gained something. I did, but the thing that I gained was an electron. An electron has a negative charge to it. Okay, so let's go ahead and move from here to the next slide. So our octet rule, we talked about this last time. Atoms tend to gain, lose, or share electrons until they have 8 valence electrons. These were the common Lewis dot symbols that we looked at. This shows all of those main group elements and the number of electrons that are drawn in their Lewis dot symbols. And basically, all of these, they are going to gain electrons, in which case they are going to have a negative charge. Boron and aluminum are a little bit tricky. The reason that they're a little bit tricky is because aluminum, well, what it likes to do is lose 3 electrons, and boron actually just likes to get 3 electrons to share. Okay. Now, what that leads us to is this table right here. These are the common ions. I want you to know these common ions. Now, with that in mind, there are some trends that you can recognize. On the left-hand side of the periodic table where I put my star, um, what are these substances classified as? Yeah, they are ions, but if I mentioned sodium or potassium, rubidium, lithium, what type of material is that? And I'll give you a little bit of a hint. It's probably going to be kind of hard. And I'll give you another hint. It starts with an M. That's the word I'm looking for. Metals. These are all metals. Okay, so then what about these over here where I've circled them? What are those classified as? Non-metals. Great job. Does anyone notice anything about a trend for the metals and their charges? Yeah, they're positive. So you can operate on the idea that, well, if something's classified as a metal, all of the things that are highlighted or that are circled here, I'm going to erase my other circle now. All of the things that are circled, they're metals. They are positive. Therefore, did they gain or lose electrons? Spot on. They lost electrons. So your metals typically are going to lose electrons. Your nonmetals are typically going to gain electrons, which is why we have things that are negatively charged. They gain something. The thing that they gained electrons. Those electrons have negative charges. Now, I want you to know all of the common ions that are listed on this table. Now, everything else that's represented by a white box, I'm not going to ask you to seek those out. Um, Iron is going to be Fe2 plus or Fe3 plus. Now, this next slide will tell us the names of these ions. And we talked about this a little bit last time, and I want to extend that discussion because one of the things that we mentioned was if I told you about Cl and versus NaCl. NaCl is what's known as an ionic compound. It's formed by Na plus and Cl minus. Now, could anyone add to the chat the name of this compound? Not table salt, but the more technical name, sodium chloride. Now, that IDE suffix, the end of chlorine, has been replaced by IDE. And you know what? That IDE right here, if something ends with IDE, that's an indication that it's a nonmetal that has gained electrons. If we compare that, so if somebody says chlorine versus chloride, One of these is an ion, the other is not. Chloride is an ion, and specifically it's known as an anion. An anion is a negatively charged ion. If you look at this table and we split it right here between 3A and 5A, I'm going to draw the divider right there. Everything above this line, there we go. Everything above that line, they are all positively charged. These are all metal ions. Now, with the knowledge that metal ions are positively charged, I want you to add to that information that a cation is a positively charged ion. So definition, positively charged ion. Okay. So anytime you hear about a cation, think, well, it's a positively charged ion. Now, what you should notice also about this group of cations is that they are all metals. So I can't think of an instance where you're going to have a nonmetal that is a cation. Metals lose electrons to become positively charged ions, aka cations. Now, in order to name a cation, all that you do is you see the element. So Na plus versus Na. The only difference between these is that Na plus is known as the sodium ion, whereas Na is sodium. So if I say, hey, you have a single sodium ion in your left hand and you have a single sodium in your right hand, I'm talking about two different things. One of them is a charged species, a charged thing, that being your sodium ion. And then the thing in your right hand, the sodium, is, well, that's simply an atom. That is not an ion. Now, below that, I'm going to draw a line right here to divide these. We've got a bunch of nonmetals. These nonmetals all form anions. And when you look at these nonmetals, one of the common features is that they have IDE, that IDE suffix. So essentially what you do is you take the word nitrogen. So if you have nitrogen, N versus N3 minus, the difference between these is N3 minus is a nitride, or is a nitride ion. N3 minus is an ion. You don't say nitrogen ion. Instead, what you do is you drop OGEN and you add IDE space and ion. So if we see bromine, for instance, we're going to give that the same treatment that we gave to chlorine. If we're talking about an ion made from bromine, it is going to be known as the bromide ion. So an example question, or one of the ways that you might see this sort of thing on your exam, would be Br minus. The appropriate name for this is A, bromine, B, bromine ion, C, bromide ion, and D, bromate. The correct answer for that would be C, a bromide ion. So a negatively charged ion, chances are it's going to have the IDE, right? A negatively charged, what's known as a monatomic ion. Could anyone tell me in the chat, what do you think monatomic stands for? Or what do you think that means? And in this case, mon, short for mono. What does mono mean? Add that to the chat. Okay. So mono atom, one atom. So then the word monatomic is basically the same as saying one atom. So a monatomic ion is a single atom that is an ion. Okay. Now the last fraction of this slide is just showing the other common ions. So copper, copper 2 ion, silver ion, zinc ion, iron 2, iron 3 ion. Does anyone notice anything about the charges and the presence of these Roman numerals? Give me a Y if you notice maybe a trend between um, the Roman numeral and the charge. Give me a Y if you do and X if you don't. Okay. So let's say hypothetically that I was doing some work and I found, I'm going to use F, I'm going to say I discovered iron 6. Could you tell me what the charge of that is? Plus 6 or 6 plus. Absolutely. Okay. Um, what about now? Absolutely. 9. Okay. Now take a look at your anions. Do the anions get any sort of Roman numeral symbol? Y or N to the chat? No. So what do you think that means with respect to a Roman numeral and a charge? Do you think that it's exclusive to positive charges? Yeah, it is. Now, with that in mind, look at silver. Silver and zinc. What does that make you think? We've got silver ion, Ag plus, and we've got a zinc ion, which is Zn2 plus. Um, why don't we have a, a Roman numeral for either of those? All right, let me rephrase that. Do you think there should be a Roman numeral for those? Y or N to the chat. Okay. Now, here's the part that's a little bit tricky about this. Let me add a little bit more information and see if you change your mind. The only known zinc ion is a 2 plus ion. There's no such thing as a zinc plus 1 ion. Do you think that we should use the Roman numerals to designate zinc? And think about in terms of copper. Well, we've got this copper cation, and then we've got this copper cation. So we've got two different copper cations, and so we use the Roman numerals there. But zinc, there's only one known cation. So that's why we don't use the Roman numerals for silver and zinc. If that makes sense, add a 1 to the chat. If that does not make sense, add a 6. Okay, 3. Okay, so when we use the Roman numerals, or the Roman numerals are used and deployed because we have multiple cations. So that Roman numeral indicates the charge of that cation. So if we're to go back to our learning objectives for today, I want you to know what are the common ions in this slide deck. So a good reference would be that slide that has all of those common ions. So we've looked at that. You guys know where that is. I'm going to put a check mark by that. Now, what are the names of the common ions? The good thing about these common ions, and I'm going to go back to this slide right here, is if you can decipher what the names of all these symbols right here are, you can just say the metal name plus the word ion. Now, here for copper and iron, on this slide, there's specific names. There's cuprous and cupric. There's ferrous and ferric. I'm not going to ask you to know those names. Instead, what I want you to be able to do is say iron 2 ion versus iron 3 ion. Same thing for copper 1 and copper 2. Aluminum, zinc, and silver, there's only one ion for each of those, so we don't use the Roman numerals. Then, every single one of these, how do you come up with that name? -IDE, ion. So you do have to negotiate and kind of navigate the word or the name, but I think that the more that you read them, you'll be a little bit more familiar. Now, just so you guys have this kind of as a record, and so I can recognize that I said it aloud, this is the nitride ion. This is the oxide ion, fluoride ion, chloride ion, sulfide ion, phosphide ion, bromide ion, and iodide ion. I say all those so that whenever the exam comes around, if you see this phosphorus ion, when you see phosphoruside as an option, you'll say, oh, that uses the IDE suffix, but there's extra letters in there. Well, that's my line connecting those two. Okay, so now we'll go back to our objectives. What are the names of the common ions? Talked about those. Now, the next thing that we're going to do is we're going to look at formulas of ionic compounds. I want you to be able to convert the formula to a name and the name of a formula to a compound. So on the surface, I would want you to see Cu2 plus and say that's copper 2. Okay. And then vice versa. If I wrote iron 2, I'd want you to say, well, that is Fe2 plus. Okay. Now, we're going to get into this, but we're not going to get into it until after our first poll question, which I'm going to launch right now. But nobody should answer it because I haven't posted the question yet. And somebody answered it. I kind of want to end the poll and restart it just so I can be like, ha, and then I'll send a sternly worded email. No, I won't. But here's the question. Oh, and somebody answered C before they saw it. Oh, they maybe looked at the slide deck. Okay, what is the name for an Ni2 plus ion? Is it the nickel ion? Is it nickelide? Is it nickel 2 ion? Is it nickel back? Well, you know that D is not the answer because it doesn't have the word ion. Spoiler. I'll give about 10 more seconds. So get your answers in. And 3, 2, 1. End poll. We got 65 participants. If you did not see it, if you did not answer it, we'll have more questions, so keep an eye out. Or be like that person who answered B before the question was even up. Okay, we had 69% of the class answer nickel 2 ion, and you are absolutely correct. C is the correct answer for this question. Now, we'll go ahead. So, an ionic compound consists of a metal and a non-metal anion. So, a metal cation and non-metal anion. Thinking ahead to the periodic table, or thinking back on the periodic table, Could you give somebody directions? Like, where are things coming from? So, where did the metal ions typically come from on the periodic table? Are they on the top, the bottom, left, right? Left. What about your non-metals? Where are they coming from typically? That's right. So, if you're saying, hey, you want to make an ionic compound? Well, get a piece from the left, get a piece from the right, put them together. Okay. An ionic compound, in addition to that, we've got a transfer of electrons. Sodium right here loses an electron. Chlorine gains an electron to become the chloride ion and the sodium ion. So NaCl, that's what it looks like. This is what it looks like kind of on the molecular level. This is what it looks like a little bit further out. And then this is what it looks like if you go get a microscope and get some table salt and look at it on the microscope. You're going to see that. You're going to be like, aha, salt crystal. It makes, I don't know, eggs taste better. Now, naming ionic compounds, you're going to use the rules that we just came up with. MgO. Does anyone know what MgO is? Add it to the chat. This is where we're taking a magnesium and an oxygen. Victor, you're absolutely correct. You are 100% correct. Magnesium oxide. We took the magnesium. Oh, well, that's an ionic compound. Does that matter? Yeah, it does. But when it comes to metal ions, do we change their names? No. All that we do is we add ion. In this case, we're making an ionic compound. So we're not talking about an individual ion, or yeah, we're instead talking about this compound that's forming. So this is magnesium oxide. Magnesium oxide. Okay. FeCl3. All right. I'm going to caution you before you start answering this question, and I know that somebody's ready to, and that's awesome. Um, let's start with Cl. What do we know about the common ion of chlorine? Can anyone tell me the charge of the common ion of chlorine? Minus. I got a private message that said it's minus. You're absolutely correct. Now, what does this 3 subscript indicate about that Cl? How many of them do we have? 3. Okay, now give me a Y or N into the chat if you would agree with me that we have 3 negative ions whenever in that circle that I just drew. Y or N to the chat if you agree with that. Okay, great. Now, could anyone add to the chat what is the total charge of 3 negatives? So if you have 3 negatives and they kind of combine together, what is that totally equal to? -3. Fantastic. Okay. Can you give me a Y or N to the chat if you agree with me that these 3 chloride ions give us a -3 charge? Okay. Those 3 chloride ions give a negative charge. Now, the next part, I got to jump back for a second. Um, this combination right here is an ionic compound. Do each of these individual things have negative and positive charges respectively? Are they both ions that come together to form something? Yes, they are. So collectively, if you write NaCl, sodium chloride, you're going to write it like this. What is the overall charge, the net charge of NaCl? A sodium ion and a chloride ion. What is the net charge? Add it to the chat. Neutral, also known as 0. Maddie, you're absolutely right. So collectively, NaCl has a 0 overall charge. Can you give me a 9 in the chat if you follow that? Okay. So here what we're doing, when 2 ions react with one another to form an ionic compound has a neutral charge. And if we look at FeCl3, Does that have a neutral charge? My question, kind of behind the question, is there any charge that is indicated right there where that arrow is? I have an arrow drawn to nothing. So is there an overall charge there? No. Okay. So FeCl3 has a zero overall charge. The three chlorides give us a -3 charge. If the chlorides give a -3 charge collectively, then what is the charge of Fe in order to neutralize that or cancel that out? Yes. Okay. So we've got that's kind of a good reference point for you to always think about and look at. In the upper right-hand corner of that molecule, we see the charge indicated. FeCl3, the overall charge is zero. Cl, there's three of them. That part of the molecule, and this is what I always like to do, is I like to take my molecule and kind of snap it in two. And I'll say, okay, well, this is -3. Therefore, this has to be +3. Okay, so what iron ion am I working with? Add it to the chat. Fe3 plus. Okay. How do we denote Fe3 plus when it comes to kind of marking that off and writing it up? What would its name be? Iron 3. Okay, perfect. So, with that in mind, this is one of the things that you need to know about ionic compounds, and this is unique for ionic compounds. Although there are three chlorines, we actually don't need to indicate there are three chlorines. The reason we don't have to indicate that is because this list right here are the common ions. So if somebody is making an ionic compound with chloride, they know that the charge of that chloride is -1. So what that means is when somebody sees this right here, they say, oh, okay, well, chloride has a -1 charge. This is iron 3. Oh, okay, well, this is iron 3 chloride. I want to stress that because there is no need for you to say iron 3 trichloride or anything like that. You don't have to indicate the number of chloride ions that there are just because the common ion of chloride is -1. The iron has a +3 charge. Therefore, +3 and -1, you have to have three of those chlorides. Okay, can you give me a 1 in the chat if, okay, I worked through it, or a 5 in the chat if you say, I followed the iron, but I got mixed up on the chloride. Can you do another example? Okay. All right. So this is taking formula to name. Now we're going to go name to formula. Calcium oxide, or calcium chloride, I'm sorry. Okay. All that we need to do is we need to think about what do we know about chloride? That has a -1 charge. Calcium. Oh, rats, I can't remember calcium. But if I look at it on the periodic table, which heck, is this shaped pretty much like the periodic table? Yes, it is. Okay. I got a question, a private message question that reads, quick question. We wouldn't say ion at the end because it's a compound, correct? Yep. Great question. Okay. Now I got a direct message that says calcium is 2 plus. So the formula for this, well, chlorine is -1, calcium is +2. We have to make this mathematically work out. So Ca, I'm going to write that. And the way that I always like to do this is I give myself a little model. There's my calcium with its two pluses. Cl with a minus. And that Cl takes care of that one. Now I need another Cl to take care of the other positive. So that gives me, I'm going to draw an arrow here, CaCl, and then I got to use a subscript to write 2. Can you give me a one in the chat if you followed that, and then a five in the chat if you say, "Oh, I don't follow that." Okay. Now I'm ready for you guys to try this next one. Sodium oxide. When you get a chance, send as a, well, you know what I'm going to do? I'm going to adjust this so that you send, never mind. Um, Add to the chat sodium oxide and include any subscripts that you need to. Okay, I got one private message answer, and I'm not going to indicate if that's right or wrong. I'm going to try to get like three answers or three responses before I dissect this one. If you need to, go back. I guess it's like maybe four slides to that common ions. Ooh, interesting. Got some interesting responses. Okay. Okay. Got two different responses. Now, now I've got three different responses. Okay, what we need to do is we need to dissect what is the charge of sodium. Sodium is a +1 cation. Now, what is the charge of oxygen? Oxygen is -2. So, in order for this to work out and be equal to zero, what do we need to have? Well, again, I'm going to draw a little model, negative, negative. There's my oxygen. I've got two negatives. Then I'm going to draw another sodium ion plus. Done. And then Na plus. Done. Okay, so I've got two sodiums. So I need to write Na2O. Each of those sodiums has a +1 charge. Each oxygen has a -2 charge. So you got to have two sodiums to equal out or cancel out the charges on those oxygens. Okay. All right, now next up, we got another Zoom poll question. And what is the name of NaF? NAF. I feel like, yeah, so far, I think that you guys are going to clear 90% correct on this one. And you know what? If we do that, I can give a bonus point on the first exam. Right now we're at 90%, 89, 87, 88, 86, 87, 88, 87. Okay, I'll give until 1 minute, which is another 15 seconds. 88. 86, 87. Oof. Close. Close. If you're having trouble seeing the question, then you probably need to look at the more function on your menu and go to polls. So the smaller charge has to make up for the bigger charge. Yeah, it's a great way of looking at it. I got that as a private message question. Okay, I'm going to go ahead and end the poll. Okay, we got to 87. Got to 87. So that one doesn't get that's not going to give us a bonus point on the first exam, but good news, there's more questions. Also, good news that I will eventually just say, okay, sounds good. We did it. Good job. I have to ask, are we expected to have these charges memorized, or are most people looking at the periodic table? That is a fantastic question. And I'm going to jump back a couple of slides. So this set of common ions is the ones that I want you guys to know. Now, with that in mind, how do most people look at this information? Most people look at this information and they just look at an element and find it on the periodic table. They say, oh, well, sodium, that's in group 1 of the periodic table, that first column. That's +1. This one's +2. Then I'm going to jump all the way across. I'm going to say, well, if it's in 7, then it's -1. If it's in 6, it's -2. And 5, -3. Now, when you look at this and you see lots of white space on here, well, I'm not going to ask about elements here, 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 and here. So it's not like, oh, well, this one's actually -4, or this one's actually -4, or this one's -5, or anything like that. The ones that I'm going to be asking about follow these general trends. So what I want you to do with that is say, okay, well, I can remember group 1, group 2, group 7, 6, 5, and then the rest of them, those are the ones that I'm going to commit to memory. Iron, +2, +3. Copper, +1, +2. Silver, zinc, aluminum. I remembered this whenever I was a student in my first chemistry class as, okay, this row was kind of like steps, +1, +2, +3. So there's little mnemonics and tools you can use to help yourself out. But to answer the question, most people are referencing their periodic table. It's not like they get a forearm tattoo of this or they've committed this to memory. Instead, they're like, I've got the periodic table on the exam. I'm going to use that. Okay. And in addition to that, what you can always do is look at this and say, okay, well, how many valence electrons does that thing have? Okay. Everything here, they all have 7 valence electrons. So what they are going to want to do is they're going to want to get one more electron to get to that complete octet. All right. So the correct answer for this, and the majority of the people got this, sodium fluoride, NaF. Sodium is +1, fluorine is -1. So combine that is going to be 0. Okay, so we can have a copy of common ions periodic table. No, I will give you a copy of the periodic table on your exam, and that is basically the exact same one. If you go to ptable.com, I'll add this to the chat. www.ptable.com. If you go to that link, that's going to be your periodic table. Essentially, a screenshot of that is what you get on the exam. And then you just kind of mentally overlay, okay, column 1, column 2, +1, +2. Column 18 are your noble gases. 17 are your -1. 16 are your -2. 15 are your -3. Okay, now we've got next poll question coming up. I'm going to launch it. What is the formula for zinc oxide found in sunscreens? Again, reference the periodic table. Reference that common ions page when answering this. If we get 90%, then we're going to get a bonus point on the exam. I'll give you a little bit of a spoiler. Oxide, -2. I'm going to give you another 32 seconds, and then I'm going to shut it down. Okay, 5 seconds. All right, I'm going to end the poll there. We didn't get it. We got kind of an what's it? The word I'm thinking of is a little bit of a random distribution. We did, however, get to the most popular answer with 55% is C, and that is the correct answer. So the correct answer for this one is indeed ZNO. Zn, the common ion for that is +2, O is -2, so Zn, and I always like to just do these little models, plus, O, minus. Oh, well, this is going to cancel and this is going to cancel. So oxygen is taking 2 electrons from zinc in order for this to form. Now, some examples of different species. Here we've got lead oxide. Lead oxide, well, that's lead 2 oxide, lead 3 oxide, lead 4 oxide. These are good questions that I want you to be familiar with. Lead has a formula or a symbol of Pb. Can anyone add to the chat what is the charge of lead 2? Add to the chat. In lead 2 oxide. +2. Okay. So if we're putting together this formula, it's going to be Pb +2 and O2 minus. So PbO. I got a private message question. What materials are we allowed to use on the test? You are allowed to use a 3x5 piece of paper or index card and scratch paper. That scratch paper has to be blank. That is it. Okay. Now, could anyone add to the chat? And again, I will talk more about the exam on Tuesday. So whatever questions you have about the exam, make sure that you bring them on Tuesday if I haven't already answered them. What's the charge of lead 3 plus? Or sorry, oopsies. Yes, that's the point of the flashcard. That's your note card. You can put whatever note on the front and back of that single, the one 3x5 index card. So you can write your common ions in there if you want. Okay, lead 3 is, okay, so this is going to be +3. This is going to be -2. Okay, I got a private message that says, oh, what about PbO3? Close, but not quite. Okay, so if you have PB2, if you have, well, actually, no, let's, somebody propose PbO3. There are 3 oxygens here. Each one of them has a -2 charge. So what is the total charge on this PbO3? On the O3s, what are what's the overall charge on O3? Exactly, it's -6. Okay, so what's the charge on lead 3? +3. Okay, so if you have one ion with a +3 charge and one ion, and then these oxide ions with a -2 charge, what's the overall kind of remainder charge on this molecule? You got a +3 and a -6, -3. Okay, we don't want it to be -3. We want it to be neutral. So what can we do to make this neutral? What if we added another Pb, 3 plus? Well, then these two Pbs would be +6. The 3 oxygens would be -6. Those two are going to combine to be 0. Does everyone agree and follow that? Add a Y or an N to the chat. Okay. Now, a little bit of a trick that you can use. And whenever I see this, and we're going to apply it to the next one, is I'm going to write Pb 3 plus, oxide, O 2 minus. Now, what I'm going to do is I'm going to erase my charges. I'm going to draw an arrow from my 3 and put it down here by the oxygen. Then I'm going to draw an arrow from my 2 and put it down here as a subscript for the Pb. So it's going to end up with Pb2O3. 2 Pb, or 2 lead 3 plus ions is +6. 3 2 minus ions is -6. Now, let's try this same sort of thing. Pb 4 plus and O 2 minus. What formula can we do to come up with something that works for this, where it is a neutral compound? Okay, Pb2O4. You're right. Now, the only additional step that you need to use for this right here is we can reduce these numbers. We can make, find that lowest common denominator, that lowest ratio. So we can say PbO2. The reason that we're switching the numbers, this is just a little bit of a trick to indicate the number of each ion that we need. So whenever I say lead 3, that indicates Pb3 plus. Could everyone give me a Y or an N to the chat if you follow that? Okay. And then could everyone give me the charge of an oxide ion? Okay. -2. So I'm going to say O2 minus. Now, what I need to do is I need to come up with, well, what's my formula here? How many Pb3 plus and how many O2 minus combine to make a neutral compound? That's my question. That's what I'm kind of tasked with. Then, what you could do is you could say, okay, well, PbO. Tell me what is the charge if I just take one Pb3 plus and one O2 minus? What's the charge of this species right here, of this whole thing, using these ions? It's -1. Okay, so that doesn't work. Because remember, I've got a lead 3 cation and an oxygen 2 minus ion, an oxygen ion, an oxide. So the little trick that you can use is to take the charges and make those charges, or make the numbers representing the charges, make them subscripts. So the 3 goes down to be a subscript for oxygen, and the 2 becomes a subscript for the lead ion. So now whenever I have 2 lead 3s, that's +6. 3 oxides is -6. That will give me my neutral ion, or my neutral compound. Can you give me a Y or an N to the chat if you follow that? Okay, great. Now we're going to move on. Okay, for this right here, tell me the charge of the copper ion in this compound that I've circled. Got a private message. I got another private message. Okay. So this whole compound, okay, this whole compound is neutral. I'm going to say neutral compound. Done. Can you give me a Y or an N to the chat if you agree with that statement? Okay, awesome. Now, give me the charge of an oxide ion. -2. Okay. For this whole thing to be neutral, what does this copper have to be? +2. Absolutely right. Fantastic. So this compound is copper 2 oxide. Can you give me a Y or an N to the chat if you follow that? Excellent. Next up, what is the charge of the oxide ion in this neutral compound? What is oxide? Oxide is -2. There are two copper ions. What is the charge of each copper ion in this compound? Okay. I'm getting a bunch of different answers. What is the charge of this compound? Add that to the chat. What charge is indicated right here? Neutral. It's 0. There is no marking right here. Okay, so this is an ionic compound. Let's set this up like a math problem. Ion charge plus ion charge equals, I'll say, compound charge. Okay, let's use that as our model. Okay, so now what is the charge of this compound? What will I put right here? Getting, okay, I got 0 and I got +2. Cu2O. There is no charge indicated for this compound, so I'm going to put a compound charge of 0. Does everyone follow that? Add a Y or an N to the chat. Okay, so I'm going to put a 0 there. And after this, I'm going to do some other examples. Now, we have to think back to the common ions, because this is ions that make up this compound. Tell me, what is the charge of an oxide ion? And if you have to, go back to that common ion slide or go to the periodic table. -2. You're absolutely correct. It's -2. So what do I have to add to -2 to equal 0? +2. Okay. Does everyone follow that? Give me a Y or N to the chat. Fantastic. Now, my next question is, how many copper ions are in this compound? Add that to the chat. Spoiler, it's not positive, it's not negative. There are 2 of them. Okay. So if the overall charge of what's in this circle right here is -2, then what is the charge of each individual copper? Yes, it is +1. So you could rewrite that and say 2, then put in parentheses +1. So this is, could anyone, yeah, could anyone put the name of this compound, convert it from formula to name? I'll give you a hint. It's copper oxide, but there's one other detail that you need to add about that. I got a private message with the correct answer. Copper, and then we put the parentheses. The parentheses, let's jump back a few. What do we put in parentheses? We put the charge of each ion. So if it's 2, then it's +2. And in this case, it's copper 1 oxide. Okay, awesome. Can you give me a Y or an N to the chat if you follow that? Okay. Now, yes, it's copper 1 2 times. Could anyone add to the chat? Yeah, there we go. Iron 3 oxide. take a minute and put that formula or put that formula together and add it to the chat. So iron is Fe. There it is. There it is. I got a private message with the exact right answer. This is iron 3 oxide. What is the charge of iron here? Add that to the chat. +3. Okay. What is the charge of oxide? -2. So we have Fe2O3. That is our formula for iron 3 oxide. Now, if you were to see something like this, FeO, that's iron oxide. What is the charge of the iron in this iron oxide right here? FeO. It's +2. Perfect. Okay. So this is not a super trivial thing, but it's a skill that I want you guys to be able to have. All right. Now, with that in mind, um, expect questions related to this on the exam. Sorry. Okay. So now what we're going to do is that was all about ionic compounds. Now we're going to go on and we're going to be emphasizing sharing electrons. Sharing electrons is also known as covalent bonding. So in covalent bonding, we have different atoms that share electrons with one another. So what I need you to know about this is something known as electronegativity. Electronegativity has a scale or a range. The most electronegative element is fluorine. That's a piece of kind of trivial but important information. Now, what does that mean? That means that when making a formula, so if I were to do this right here, draw a line between N and F, that would be, this represents 2 electrons shared between a nitrogen atom and a fluorine atom. So if I drew this, CH, that represents 2 electrons being shared between carbon and hydrogen. Can you give me a Y in the chat if you follow that, and N in the chat if you say I don't follow that? Okay. Now, this is an important foundation because when you share something, like my kids have toys and sometimes they're good about sharing them. And whenever they share them, sometimes they're good about evenly sharing them. Um, but then others they're not. So they have a Switch, a Nintendo Switch, and we bought it for all of them. But can anyone relate to the idea of, oh yeah, we bought this together, but one of us really likes it, and the other one kind of. So my oldest son, he uses the Switch almost like, well, this is my Switch. Instead, me and my wife have to correct that and be like, no, it's not your Switch, it's you guys' Switch. So it's shared amongst all of you. So each one of you has kind of an ownership fraction. He's like, yeah, but Let's just put it in my room. And we're like, no, that's not happening. The same sort of thing happens here. Fluorine is the most electronegative element. And it has a score, you could say, of here it reads 3.98, but you could basically call it a score of 4. Nitrogen has an electronegativity of 3. Okay. So the highest electronegativity is 4, the lowest is basically 0. What this means is that fluorine, whenever it is sharing electrons with another element, it wants those electrons more. So you could look at it almost like, well, nitrogen's rolling in with a strength of 3, and fluorine's rolling in with a strength of 4. Can you give me a 1 in the chat if you follow that, a 2 if you do not follow that? Okay. So now, and this is kind of tough to see, but let's say that I gave you a formula. And I said, all right, well, we've got electrons being shared between phosphorus, P, and sulfur, S. And if you have this slide deck open on your own computer, that might be better, but I can actually zoom in. I want you to add to the chat which of these two elements, P or S, has a greater claim to these electrons. I'm seeing lots of S's, and you're absolutely right, because it's more electronegative. Now, all of these little numbers underneath the names of the elements, all I want you guys to do is memorize all of those numbers. It's really not that many. Ha 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 ha. Just kidding. I don't want you to memorize those numbers. And this is the downside of a remote class because I cannot see everyone's eyes rolling simultaneously. Thank you. Thank you. Um, so I don't want you to memorize those numbers. Do not even think about memorizing those numbers, please. I will give you these numbers when they are important. Now, what I want you guys to, okay, I apologize. I'm apologizing. I've gotten 3 messages saying mini heart attack or something of the like. I do not want you to memorize these numbers. Okay. Now, if we were to take the strengths, think about these numbers as strengths. The higher the number, the stronger the pull is for one atom to want those electrons more than another one. Can you give me a Y or an N if you follow that? Okay. So we just did sulfur versus phosphorus. Sulfur has 2.58, phosphorus is 2.19. And everyone kind of agreed that sulfur wants those electrons more. It's more electronegative. Now, if we were to compare chlorine and phosphorus, say that we had another bond that was PCl. I'm going to label it A and B. Which one of these two bonds has a greater difference in those electronegativity values? B. You're absolutely right. Because the difference between those electronegativities is kind of, well, it's more dramatic. You could almost think about this, and the way that I always try to think about this, and the way that I think is helpful to think about this is to say, okay, it's a game of tug of war. When we compare phosphorus and sulfur, it's almost like, let's say, because my kids are in elementary school, a third grader versus a fourth grader in a tug of war battle. So we got a third grader and a fourth grader playing tug of war. And those differences, 2.19 versus 2.58. Whereas in model B here, we've got that same third grader versus let's say, eighth grader. Can everyone follow the logic of my comparison at a 1 if you follow, or a Y if you follow, or a 2 if that's totally unrelatable? Okay. So that's what we're looking for. We're looking to find which elements are more electronegative to see the greater discrepancy between these. Now, we classify these bonds. So what we've got is what's known as bond polarity. We have bonds and we classify them. So we have a covalent bond that we classify as a non-polar covalent bond, where we see an electronegativity difference of 0.5. Now, if we go back, phosphorus and sulfur. Phosphorus has a value of 2.19 versus 2.58. Is the difference between those less than 0.5? Add a Y or an N to the chat. Yes, it is. Because 2.58 minus 2.19 would be something like 0.39 or something. Okay. Now, what that means is that if we had a phosphorus sulfur bond, we would classify it as a non-polar covalent bond because the electronegativity difference is less than 5. Now, nope, that's leading up to our last poll question of the day. Phosphorus versus chlorine. Okay. 3.16 versus 2.19. Make an approximation. What's the difference between these two values? You could say roughly 0.97. I like it. So is that greater than 0.5? It is. So when we were looking at these bonds, PS, okay, it's about 0.39. PCl. So this one is a nonpolar covalent bond. PCl, the difference here is roughly 1. Is this bond right here, is our electronegativity difference there, is that a nonpolar covalent bond? Nope. So now what we have to do is we say, well, this isn't that battle between a third grader and a fourth grader. One of these is going to win, and one of these is going to win by a lot. Chlorine has a much greater electronegativity, greater strength. So our difference of approximately 1, we're going to elevate this to the next category. That electronegativity difference is greater than 0.5, or it's between 0.5 and 2. Therefore, we would qualify this or classify this as a polar covalent bond. Does everyone follow that? Give me a 7 in the chat if you follow that. Okay. So whenever we talk about bonds, we classify them as nonpolar covalent if the electronegativity difference is small. If the electronegativity difference is between 0.5 and 2, we classify it as a polar covalent bond. If it's greater than 2, we classify that as an ionic bond. In an ionic bond, electrons not even being shared. They are transferred. Therefore, you make ions in this process. Now, with that, let's go ahead and open up our last poll question for the day. And what I'm going to do is I'm just going to open up my last poll question of the day. And this is where we are going to stop for today. We'll pick up the rest of this on Tuesday and integrate this as a part of your exam. And when I'm writing the exam, I'll let you guys know over the weekend, like, hey, this is where the stuff stopped for the exam. Okay, so which bond is the most polar? So you should be answering this based on which electronegativity difference is the greatest. After you've answered this question, I hope that you have a great day, hang around if you've got some questions. I've got office hours starting at 11. If you want to join, go ahead and join the link through our Canvas page. Other than that, though, yeah, if you got questions, we can meet on Zoom on, tomorrow or Friday. Just let me know. And I want to make sure that you guys do well on this first exam to set yourself up for a strong semester. If you go to the football game, sunscreen and water. Lots of both. Or I suggest lots of both. Maybe even more water than sunscreen because you can get in the shade. But, you know. I bring that up because my mother several years ago had suffered from melanoma. Thankfully, she's cancer